This is a durable cabinet by Livspace. It is very likely that decades from now, when the world is submerged due to climate change, marine archaeologists will find this cabinet still standing. How? Because it's built to last. Built to stand the test of time. Built to withstand every cabinet's worst nightmare: water. Oh my God, you were supposed to wait till I left the scene.
I'm sorry, I thought the cue was water.
You thought that... Anyway, in this video, we're going to take you through how we take great design, how we wrangle with the complexity of building a kitchen or a wardrobe, which in most cases has thousands of parts, and turn it into durable and beautiful modular interiors. It all begins here, the design phase. We've dug through a lot of data to understand the nuances and idiosyncrasies of the Indian consumer, and our designs reflect these needs. Our designers are equipped with a tool that allows them to rapid prototype designs and give you the ability to understand and actually visualize what you are getting in 3D. So you, as a customer, can see the 3D simulation and say stuff like, I don't like black. Can that drawer be a little bigger? So the door opens up, is it? No, my mother-in-law will have something to say. And once the customer says, this is it, we use the 3D model to extrapolate extremely detailed engineering drawings that our machines can read and manufacture. That's right. Almost all our manufacturing is automated and done by machines. They are pretty good at this stuff. Yeah, I do think the machines are taking over. But before we go there, it would be an absolute understatement to say that we obsess over the quality of the raw materials we use. And I mean, like, obsess. Like, really, to the point that it's becoming a problem. During the sourcing phase, we get very picky. Be it the core material, the laminates, the hardware, the accessories, everything is tested vigorously. Strength tests, borer-termite tests, we test moisture content levels, emission levels. If only we could put our politicians through this kind of scrutiny before we elect them. Now that we've sourced materials, let's start with the manufacturing phase. Once your design is complete, every single panel is allotted a unique machine-readable barcode. Think of it like DNA. It has every instruction of how this panel should be made, from its dimensions to the finish, down to the millimeter accurate position of where a hole needs to be bored. This is also, by the way, how we easily track what stage your order is at. Now, the plywood, or MDF or particle board, we call this the core material, is first laminated using our automated anti-bubble technology. We use a specific low viscosity glue, a synthetic resin, and we apply it evenly to the core material with a roller. Viscosity refers to the thickness and the density of the material. So, this is regular glue, and this is our special glue. Notice how gluggy regular glue is compared to ours? This low viscosity glue has far greater spreadability. Once the core material is glued, the laminate is carefully placed on top of it. This is then hot pressed at a temperature of 65 to 75 degrees centigrade and at a pressure of 120 tons spread across the panel for 6 to 7 minutes. After 7 minutes, we take the board out from the machine and allow it to cool for around 4 to 6 hours, creating a laminated panel that will never peel off and has an even bubble-free surface. The laminated core material is now cut into panels of the specific required sizes. A beam saw machine gets this exactly right, down to the very last millimeter. When this is done, it's time to seal these edges with an edge band. Our AquaBlock technology uses an automated edge banding machine that melts thermoplastic polymer pellets into a molten glue and pastes the edge band onto the panel. Laser sensors detect the presence of any sharp edges and the machine smoothens them out. Note, no humans involved. Edge banding is a critical step. It's when the core material is rendered waterproof and is hermetically sealed from the elements. Next is the boring of holes. Again, there's no carpenter with a pencil behind his ear marking out these spots. A CNC machine follows the instructions on the barcode and ensures an error-free boring process. No pun intended. If the holes are off by even a millimeter, your modular units will look wonky. Or worse still, they just won't fit together. So, we've got our panel laminated, cut, edge bands pasted, and the holes bored. Is it ready to be shipped? Not quite. Now, it's the QC phase. A dedicated team will now check every panel for defects, scratches, air bubbles, dust, accuracy. Is it the right laminate, the right dimension? Are the holes in the right place? Now we can finally move on to the last phase, packaging. The panels are flat packed to minimize any physical stress on them during shipping. Corner protectors, corrugated sheets, bubble wrap, all are used to ensure that your panels are well protected during transit. In fact, we conduct regular drop tests to ensure that the packaging material we use is more than sufficient. Drop tests, most fun job ever! Am I talking extra loudly because of the earmuffs? Huh? The panels are now finally ready to be shipped and sent on their last journey to your house. When they reach, an assembly team will oh so satisfyingly put them together like a precision Lego set. And voila! Not only does it look spectacular, it's built like a tank. In fact, we regularly conduct finished goods tests, which is a fancy technical term for slamming, kicking, and just generally being really violent. See? Nothing happened. Nothing happened. These soft close fittings are so boring. Really takes the fun out of slamming things.